as a data scientist, you are a purveyor of truth. And you have to really get comfortable with telling people no. At a management level, they don't really understand what data science is or what it's capable of. They just hear these magic words, data science, AI. I think you're going to see a shift away from some of the traditional machine learning stuff into more simulation-based modeling. If we can simulate out the future, we can explore all the different alternative possibilities, and that really opens up a whole new frontier.
Hello, this is Conversations in Artificial Intelligence. This is Paolo, your host, and today we're going to talk about a super interesting topic, which is basically how do we form the data scientists and the artificial intelligence specialists of the future, and what that means for your career, what that means for your company, what that means for the society in broader terms. So with me today, we have Casey Bennett, who is a data scientist working in the field of healthcare. He is a professor at DePaul University in Chicago. He has been invited to several events as a speaker and keynote speaker, and he has also been a TED speaker at one event on artificial intelligence and healthcare. Hello, Casey. How are you today?
I'm good. Thank you for having me.
Thank you so much for being here, and it is a great pleasure. So there is one thing I like to ask to my guests in this show, and it's basically, how did you stumble upon artificial intelligence?
Yeah. So a long time ago, I kind of came into it through a circuitous route. A long time ago, I started off as doing bioinformatics sort of and genetics, and over time, that kind of transitioned into doing more healthcare stuff. And as you may be aware, there's a huge need in the healthcare space for trying to figure out how to deal with the massive amounts of data that we collect about patients and all that. And so it's an area that's ripe for AI approaches, and machine learning and all those things. So it was kind of an accident, to be honest with you. I didn't set out to do it. But here I am today.
Right. So today you work in healthcare. Maybe before we go into the topic of the day, I would like to kind of get an overview a little bit about the work that you do in healthcare, and maybe just knowing a little bit about it.
Yeah. So I started off doing this way back in like 2003. I was trying to convince people to implement neural networks in their electronic health records. As you can imagine, people thought I was crazy for about 10 years, but now everybody does it. And so, I've been doing this sort of whole schematic of trying to find ways to create data-driven approaches in healthcare. How can we tailor treatments specifically for a particular patient? How can we take advantage of data from outside the clinic, from sensors, from robots that we may put into people's homes or that may be in our environment, from smartphones, from all this stuff. So really, all my research is built around the idea of how can we make better healthcare decisions, leveraging the data we collect both inside the clinic and outside the clinic. So that includes things like building machine learning algorithms on electronic health record data. It includes studies where we put robots into people's homes who have chronic health conditions, these little furry, cuddly robotic pets, and collect the data and try to use that to infer if they're getting better or getting worse, and then try to relay that information to the doctor. It's kind of a wide array of things, but it's all built around the idea of trying to figure out how to make better treatment decisions for patients.
What are the various professionals that we see in the in a pipeline, in the technical pipeline of artificial intelligence?
5 years ago, data scientist wasn't really even a word. It was kind of coming about, and it's kind of, people have thrown it around since the 90s, but it's only really been in the last 5 or 10 years that it's become this defined thing that people do. And so it's kind of like the Wild West in that people are just kind of making up their own definitions of what it is. It's hard to define. I'm actually on an ACM work group committee trying to figure out what does it mean to be a data scientist? What are the skills? What do they need to know how to do? I would say to your question, there's several different job titles that are out there. You'll see like machine learning engineer and data scientist and data engineer and AI research science, all these things. And it's not really well defined what these topics are. I would say in short that data science has become synonymous with machine learning and AI. Although if you look at what a lot of data scientists are doing, it's not necessarily AI. And a lot of them, because it's been such a gold rush in the last few years, a lot of them aren't well prepared to do the things that really people are expecting them to do. And there's actually, I think, been some disappointment on the industry side when they hire data scientists that they're not getting the return on investment. And I think that's an area we can improve on from an education standpoint.
So why people are not getting the return on investment?
Yeah, so I have a paper coming out with this work group where we go into this in detail and we do all these empirical analyses. We look at job board postings. We look at self-reported data scientists, like what they actually do. We look at educational programs. I think it's twofold, really. On one hand, you have expectations that are probably not the correct expectations. People don't, at a management level, they don't really understand what data science is or what it's capable of. They just hear these magic words, data science, AI, and they think, oh, I need to get me some of that. And so they don't have clear expectations about what they want the data scientist to do. On the flip side, you have a lot of people who are calling themselves data scientists now who aren't really trained in the conceptually. I teach it, and I have kids who come into my master's level program who don't even know who Claude Shannon is. They're not familiar with information theory, or vice versa. They don't have basic statistical training. You just have people who are missing elements of what they need to know. So I think part of it's like data scientists themselves. There's such a wide array of who calls themselves a data scientist, and some people are very technical, and some people are just data analysts who've decided I'm a data scientist now. And then you have incorrect expectations on the other hand, with the jobs. I like to joke my grandma says she's a data scientist now because she uses an algorithm when she bakes pies. So she's like, I'm a data scientist. I use a recipe, so I'm a data scientist too. So it's like, if anybody can be a data scientist, then what is a data scientist? We need better definitions and clearer expectations.
So let's give, if you like, our audience possibly an example of a situation like this, because you're talking about some of the professionals not having the theoretical background that is necessary, but that conflicts with the, if you like, a lot of educational resources out there that are actually trying to do the opposite, like the quick, if you like, the 5 steps to become data scientist and making 200K a year, and so on and so forth. So that's kind of the market that is out there. But can you give an example of situations where these cheaply made data scientists do not perform as expected and the ROI is not what expected?
A great example, and I run into this in my classes, and I've done hiring for 2 Fortune 100 companies, 2 of the largest companies in the world in healthcare, 2 of the largest healthcare companies. And I've seen this in job interviews too. But there's tons of examples, but a classic one would be feature selection, right? So what is feature selection? You ask people, and the only thing they can say is, well, I use PCA, blah, blah, blah. PCA is technically not a kind of feature selection. It's a type of feature extraction. So they haven't actually been trained in the methods, and they have a misunderstanding of the tools. And the problem is, if you don't understand the tools, you're going to misapply them, right? Like the English idiom, if all you have is a hammer, everything looks like a nail, right? And everything looks like a nail, and you're just trying to hammer everything, regardless of whether that's the right tool for the job. And so that, I think, is a great example where, we need clear definitions of what the skill set is, and make sure that the curriculum that's training these kids is actually touching on all these subjects. And because otherwise you hire people, they come in and they can't really do the job, right? So feature selection, like I said, is really critical to explaining why, right? So I can build my neural network, whatever, and tell you the accuracy of my model, but all that says is there's a pattern there. It doesn't tell me why it's occurring. And so if you're not trained in those techniques, these other additional skills, you can't actually tell people why the pattern is happening and what to do about it, right? You're missing a critical ingredient to the sort of total recipe. And that's just one example. And there's tons I can pull out of where people are just not really being prepared in a holistic way that they really need to be successful individually, but also for companies to get that return on investment in data science and AI and machine learning, you know.
I have been in the position of helping HR department to hire professionals. And one of the things where they struggle is about the background of these various professionals. And the reason is we are relatively in an initial phase, although there are specialized degrees today, but for the more experienced people, you're going to find them that they didn't have a master in AI
Right. Yeah.
or something like this. They usually were some other type of professionals. So in this confusion, one thing that is very complicated to understand for, I think, recruiters and also companies, there is a large difference in price, is the difference between somebody who has a PhD and somebody who is not. Where do you think the difference lies, and if there is a reason for companies for certain problems to focus more on a professional that perhaps more expensive?
Yeah, I mean, I think somebody who has a PhD, you have a better chance of finding somebody who has that broader set of skills, but it's no guarantee. And I've interviewed people who have PhDs for data science positions who didn't. So you do increase the potential to have somebody who's going to have that broader set of skills, but you know, it really depends on where they were trained and who taught them and whether, you know, I think another problem is that we have people who are learning data science from people who've never been a data scientist because programs are just they're grabbing anybody who knows statistics or computer science and having them teach data science courses. So sometimes these kids are coming out of these programs and they're not really well prepared. I would say it's more important the program and the curriculum than necessarily whether they have a PhD or a master's or whatever. There is probably a greater chance if you hire someone with a PhD, they're going to have those skills because they've been involved in research and that kind of empirical thinking. But it's not a guarantee, you know what I mean? And you'll find that people with master's degrees or whatever who actually will do better work than a PhD sometimes, you know? So there are no black and white rules, I would say.
You like it or you don't like it. Data scientists are paid more than traditional engineers. In Silicon Valley, we have situations where data scientists is paid even $1 million. Some are paid $2 million. I mean, that's an extreme, okay? But if the normal engineers in Silicon Valley is paid 140, 160, 180K, the data scientist is certainly paid above 200K, from 200 to 300K. So there is a net clear difference in salary. So do you think that there is a way to make an engineer that was an engineer a data scientist?
I think that without some formal training, I don't think it's necessarily possible. I mean, you know, undergraduate computer science education is largely focused on, you know, the nuts and bolts, the technical details of how to do, you know, build, you know, software or build architect systems. Data science is really a way of thinking. It's, you know, and AI as well. It's really an empirical approach, a data driven approach to trying to solve problems. And that mindset is very difficult. It's almost like law school. You know, when you go to law school, a lot of what law school does is train you how to think like a lawyer. And I think that data science programs really, although a lot of them don't do it so well, really the focus is on trying to teach you how to think like a data scientist, which is a very different way of approaching problems than lay people do. It's very much focused on what is the data telling me? What are the patterns there? How can I create some sort of actionable solution? How can I leverage natural intelligence to create artificially intelligent solutions? So I really do think it requires training in that sort of way of thinking. And I don't think you can just move over, even if you know some of the skills and do it. People do it, you know, and people hire them and maybe that works out. I've seen that not be so successful though at some of, you know, I've worked at CVS, I've worked at Cigna, I've worked at Centerstone, some of the largest healthcare companies in the world. It's very hit or miss. It's a very hit or miss approach, I would say.
How should the curriculum be designed for providing the right mindset?
I mean, teaching a mindset's hard, you know, so I'm not gonna gloss over that. We have some papers coming out and we've looked at exactly, you know, how did the legal field deal with this? How did the medical field, you know, this is not the first time people have faced a problem where you have a new emerging field of, modern law or modern medicine or data science. And people had to say, look, how are we going to teach kids to kind of think, like, somebody who's been doing it for 30 years. And they came up with methods, there are methods in the law field, for instance, Langsdale's case method that's still used in almost every law school. And, it's funny when you have kids who come into law school, they've shown scientifically that within just a few months, they completely changed their logical approach to thinking about problems. They start talking like lawyers, like you and I would have no idea what they're talking about. We don't think about it that way, but they have this way of teaching a mindset, and I think that's something really critical for the curriculum. You need the skills, obviously, you need the stats, you need the programming, you need the machine learning, you need all those things, but you also have to teach this empirical approach to problem solving. And data scientist has the word scientist in it for a reason. It is a scientific approach to problem solving, and so that needs to be taught. So I think there's, I think the curriculum, like I'm babbling here a little bit. Every program you look at in the world, I think the curriculum is not very well designed. Everywhere you look, I think you have classes that overlap. You have too much statistics or too much computer programming. What we need to do is clearly delineate, things like data engineering and the foundations of data science, machine learning, data visualization, basic stats, some programming type stuff, courses on sort of the philosophy behind AI, right? If you don't understand where a neural network comes from, if you've never been taught the sort of history of the thinking of why we're doing it this way, then you don't understand what you're doing, right? You're essentially just, a human calculator. And so we need all these things to come together. And that's something that I'm working on and other people are working on, is trying to say, we can do this a lot better than we're doing it right now. We can train better data scientists. We can train better AI professionals. And the last point I'll make is that if we also create courses that we teach the general population, so data science for non-majors, then if we increase the technical literacy of our population, then it increases the complexity of the technologies we can design, right? The technical capacity of the general population is a limiting factor. People only can deal with technology that's so complex. We can only build technology so complex. It's like your grandparents couldn't even use a VCR. But now these kids, they're so smart, we're building all these crazy smartphone apps and all this stuff. So the technical literacy of the general population is something that's important for us to improve upon. So we need these gen ed courses around this stuff as well.
So data science, as you said, as the word science. Science means experimental method. Science means dealing with the extreme ambiguity and trying to identify a pattern in that ambiguity. But when you go about identifying patterns in an ambiguity, you also have to go with the mindset that you are making a mistake, and you have somehow to assess what type of error you're making. Where do you think the current education available lack the ability to convey these skills?
I think there's a lack of conceptual understanding being taught. Like, right, you can teach people how to build do statistics, how to create a linear regression model. You can teach people how to program in Python, and they can go out and download Scikit and build a neural network. But regardless of those skills, people need to have a conceptual understanding of what they're doing and why. Because when you're doing data science, really what you're doing when you tweak those parameters, when you pull in another feature into your data set, when you do some pre-processing, when you normalize data, every single one of those is essentially an experiment. You're essentially running experiments. And so you need to take that empirical approach of not trying to rely on black and white statistical thinking, or not just doing some programming and spitting out a neural network and saying I'm done, but truly understanding what you're doing and that sort of interpretation piece. And like you said, there's biases. No matter what you do, there's 1,000 different ways you can do it. And the only way to figure out the right way to do it is to run experiments, that empirical approach, right? And that kind of conceptual sort of, this is how you have to think about it. There's way too many people who just learn some statistics or learn some programming, they produce a model, and they're like, I'm done. But the reality is you're not done. You have to be comfortable living in this world where you have evidence that supports a hypothesis, but that doesn't mean you have the answer. It means you have a possible answer. And that sort of thinking, that conceptual understanding, that's That's where I see the failure. It's just people jumping to conclusions, people misapplying modeling methods, people not exploring other alternative possibilities, and all of that is from a lack of conceptual understanding.
So do you think the communication is a part of communicating ideas and interacting with non-technical is part of what a curriculum for data scientists should do?
Yeah, I think communication is critical. I tell my students all the time that, as a data scientist, part of your job is to be a storyteller. You create stories around data. And if you can't persuade people to adopt the models or the patterns that you find, if you can't persuade people to adopt the things that you find or that you build, then you essentially accomplish zero. It doesn't matter how accurate your model is or anything else. That persuasion is really a critical skill. And so the ability to be a storyteller, I think, is absolutely fundamental. And I think that gets back to the conceptual understanding. I mean, look, I can explain neural networks to somebody who's in sixth grade because I understand it on a very conceptual level. And I can explain, like, this is how humans solve this problem. And this is what neural network is essentially doing. As a data scientist, you have to be able to do that. Because, like you say, most of the people you're going to deal with are only going to have a vague understanding of any of this stuff. And so you really have to become a storyteller. It's, I think, a really critical skill. I agree with that.
So another aspect of this is once a data scientist is in a unit, and of course is going to have a supervisor maybe, but this unit is embedded into a business. My experience, but it might change from company to company, and what we call the manager in different ways. But there's going to be somebody on the business side that is somewhat setting up the direction, like we're going to do this rather than this other thing. And now some of the challenges come up is that this person sometimes also needs some level of education.
I'll say this without naming any particular companies, but I've dealt with a lot of companies. I would say a lot of the people who are managing data scientists right now on the industry side, they lack some understanding about what data scientists can actually do. It's almost like having a football team and hiring somebody who's never played football before to manage it. It's kind of like it's probably not going to work out so well, even if you have really good players. What I tell my students and other data scientists all the time is that you have to get comfortable with telling people no. As a data scientist or as an AI person, a machine learning person, there's a lot of misconceptions, amongst people who come from different areas or, lay people. And you have to get comfortable. People often say, hey, build me this model. I want to predict, how many customers, patients, whatever, are going to do this next month, whatever. And you may have to come back to them and say, you can't do that. Either we can't do it with the data that we have, or maybe it's just there's no predictability to it. And you have to really get comfortable with telling people no. Your job is not to go out there and build accurate models. Your job is to be a purveyor of truth. And I emphasize that all the time. As a data scientist, you are a purveyor of truth. Sometimes the answer is yes, but sometimes it's no. And one of my real annoyances with people in data science is they're only focused on building the most accurate model. But that's not the job. Sometimes a negative result, sometimes saying, hey, there is no pattern is useful information as well. And you have to be comfortable with saying no to those people. Because like you say, there are people in that sort of management level role who don't always understand what data science is or what you're capable of. In terms of their education, hopefully that just gets better over time as people who are in data science positions now move up to manage data scientists. Otherwise, I don't really know how you're going to train people to manage data science. Like, you can't really, have a football coach who's never played football, but that's where we're at.
So companies have a challenge today to hire. I know for a fact that some of them invest into education. So if they were to invest into additional education, what is the advice to give to these companies? What should they do?
What I would honestly say, and like I say, it depends on the people who are teaching or training these people or mentoring them. There are people out there who've been doing data science like myself back before it was a word. 10, 15 years, we called ourselves something different, until the last few years, but we've been doing these same things of building machine learning models and trying to apply AI stuff. I do it in healthcare, but there are people who do it in other industries. one thing I would say is really useful is to find somebody who's done it for a long time and have those people mentor those people, because the people who've done it for a long time, they know what the job actually entails and what you need to do to be successful. And so what I would say is a good strategy is to try to find, some of those people who've done it for a long time and actually have the practical experience, because it's really hit or miss with the boot camps, with the university programs, with any of the other things. It really comes down to who's teaching it, and do those people who are teaching it, are they teaching it from a place of practical experience, or are they teaching it more from a sort of a theoretical understanding of what they read in a book somewhere or whatever? So, what I would recommend is finding those people who are experienced and using those people as mentors, whether that's within a formal education program or within a training program within your company. Either way,
Here is a very simple question. Where do you see the future of innovation in AI in the next 5 years?
Yeah, it's funny because I've been doing this for almost 20 years now, like I said, since the early 2000s. And so I've seen a lot of, when I started off, people would call me crazy. And now everybody does those things that I did, a long time ago that they called me crazy for 10, 15 years ago. Now everybody's just like, oh, yeah, we're going to do that. And sometimes when I go to places, people are already talking about stuff that I used to fight with people over, saying, look, this is where things are going. So, to your question, I think we're seeing a transition in the data science field. I think that a lot of people are just kind of doing what people did 5 years ago, which is building machine learning models to predict things. And that's fine, but I think that's going to become more and more commoditized. You see tools like H2O, Data Robot, these other technologies that are coming out that are going to commoditize a lot of the sort of basic functions of data science and machine learning, AI, what have you. I think what we're going to see is a shift in terms of the kind of data people are working with. Internet of Things, I think, is going to become huge as these devices. People are not going to get rid of their devices. We're just going to see more and more of them. So how do you leverage the information coming from these interconnected devices that are in people's homes, that are in their daily lives, to help make decisions, right? Maybe about healthcare or other kinds of decisions, right? It could apply to lots of industries, the auto industry, insurance industry, what have you. So I think Internet of Things is going to become huge. I think, we're also going to see more robotics. I think not just surgical robots, those have been around for a while, or factory robots. I think robots are going to continue to creep into people's daily lives. Like I said, a lot of the work I do right now, and it's really started to focus on over the last 5 years, is these furry telly robotic pets. We put them into people's homes. And of course, we're interested in using them for healthcare applications, but I think they have a wide array of applications. I think one issue we have is that we really need to be training students now for the world of tomorrow. And just like people thought I was crazy 15 years ago, now when I go places and I start talking about robotic pets and robots, hanging out, and we're going to use that data, people are like, yeah, it sounds cool, whatever, but that's, pie in the sky kind of stuff. But I'm like, no, trust me, 10 years from now, this is what you're going to need to know. This is where we're going to be, in the next 10 or 15 years. And I think we should be training students right now for that. This different kind of data, right? There's new data streams. A lot of the basic stuff that we've already done is going to become commoditized. And really what's going to be valuable for data scientists and AI professionals and companies going forward is figuring out how to use these new data sources to develop new kinds of technologies. So that's my answer to that.
So where you think the AI itself will go, in the sense that we will have a new source of data, we will have new applications, but do you expect that AI will get to a next level?
Yeah, I think you're going to see a shift away from, a lot of the machine learning algorithms that are existing today are really focused on prediction of some event, what have you, or is this picture a cat or a dog, or does this person have a tumor or not a tumor, what have you. I think you're going to see a shift away from some of the traditional machine learning stuff into more simulation-based modeling. I've done over the last few years, I've done less and less sort of traditional build a neural network, build a Bayesian classifier, whatever. And I've been doing more and more simulation stuff. It comes down to this issue of, and you talk to anybody in the AI field, they'll tell you this, is any particular approach, any particular algorithm is going to solve some set of problems, but it's not going to solve every set of problems. right? So like deep learning, right, is really good at classifying images, but for other kinds of problems, it doesn't work so well, you know. And so what we need are a wide array of approaches. And I think you're going to see more and more of a movement away from traditional, what we call machine learning type stuff, the stuff you see in Scikit and Spark, and people doing more simulation-based approaches. Well, I got this massive amount of data in real time from people's daily lives. And so we really have the capability of starting to simulate out these sort of what-if scenarios of if certain things happen, rather than just trying to predict, you know, yes versus no, black versus white, tumor versus not tumor. And so I think simulation-based modeling, agent-based simulations, multi-agent simulations, I think that's really going to become more and more important with AI moving forward. If we can simulate out the future, what may happen, rather than just trying to make a prediction, we can explore all the different alternative possibilities. And that really opens up a whole new frontier in artificial intelligence.
You know, our time is coming to an end. If you have questions about this, please comment below or reach out to me. If you have suggestions about other videos that we could create in this area, please reach out to me. For the time being, Casey, thank you so much. This was such an interesting conversation.
And thank you for having me. It's been a pleasure.